Here's a quick review for the exam this week, and I'm going to use only Excel. And remember, you have access to Excel through the ACVDI. And I'm going to answer all the questions in, I guess, column A in this kind of a peach color. And if you look, some of them are highlighted in yellow. Those are the buttons that are most common on your Hewlett-Packard 10B2. In addition, those are the ones that you filled in when you created a timeline, if you ever created a timeline. Now I'm going to try to answer each one in blue and explain each one how it might be worded on an exam. And I'm going to start with the simplest one, is just the future value. So I'm going to go to Formulas and Finance, and there's future value. Pull this over here, and now I'm going to go ahead and answer this question, and I'm going to refer to it a few things that are important to remember. So rate is 10%, 5 years, 0 payment, and I started with $100. Now let me hit OK. Now what is this problem saying? It could be this. I put $100 in the bank today. It grew over 5 years at 10% each year. Therefore, in 5 years, it'd be worth $161.05. To undo future value, or if you looked at the formula, which I don't have the formula here, it was multiplication, but to undo this one for present value is the opposite. We divide, but we don't have another formula, so I'm going to go ahead and populate this blue and just find present value. Now, a few things you're probably looking as I'm doing this problem is, why was one negative? I'll show you in just a second. 10%, 5 years, 0 payment, and let's see, future value. Okay, so a few things. I always make my future value positive and my present value negative. It's kind of like if you've read a physics class, when things are going away from you, vectors, we make them negative. So if you put money in the bank or you made a payment, it's negative so that you can come back and get a positive amount. So in essence, I'm saying I put $100 in the bank today and I came back and withdrew at 161. Or I can put $620.92 in the bank today and go back 5 years from now at 10% and withdraw my $1,000. It's kind of how we do time value of money. We're comparing like terms at different times. Now, these were just lump sums. Let's do an annuity. And again, one thing I don't know if I mentioned, but this percent sign, it's got to be there. If not, Excel won't be able to answer it properly. It's going to make it a whole number. So this little A here stands for annuities, just a fancy word for a series of equal payments made at equal times. So I'm not using anything unusual here. The same future value. The only difference now is instead of populating PV, that I put the money in the bank today and let it sit, I'm just making payments. So here's 10%, and here's my number of payments, and that's my payment amount, and it grew to $610. Of course, if you make 5 payments of $500, it better be greater than $500, $610.51. Now let's do the opposite. Let's find the PV of annuities, or present value. Same formula I used. The only difference, I don't populate let's see, let's just go ahead and do it. 5 periods, and here's my payment, and I'll hit OK. Now, here's a tricky one. This is a really important payment, and I could have just left this if I wanted to. I don't want to get rid of my 1, but I could have did it this way and just deleted. And if I hit OK, it'll change that to a negative number. Either way, it doesn't make any difference. But this is a difficult problem to understand for a lot of students. Present value is really important. It could be this. How much would you spend today to receive 5 $1,000 payments over the next 5 years at 10%? Or, for instance, what if, how much would you pay for equipment that's going to save you $1,000 1 year from now, 2 years from now, 3 years from now, 4 years from now, 5 years from now? Well, you wouldn't spend a penny more than $37.90.79 if 10% is the rate that we're using. It's kind of how we do Chapter 11 capital budgeting. This is how much you'd spend for these $5,000 made at each period, 1 period, 2 period, 3, 4, 5. Don't add them up, because if you do that, you're going to confuse yourself. That's $5,000. No, it's $1,000 1 year from now, $1,000 2 years from now, $1,000 3 years from now, and you would see that this lump sum is equivalent to those payments at that period of time. Now, let's go to annuity due. Annuity, again, just means payment. Annuity due means the payment came 1 period earlier or at the beginning. It's the same answer I'm looking for. I'm looking for future value. The only difference is there's your 10%, there's your 5 payments, and your payments of $100. And you see here, I got $610.51, which is exactly what I got here. However, since it's an annuity due, it's made at the beginning. I just shifted all the payments one period, so you got to come down here to this little type thing here and put a 1. Hit OK. Now I can do this problem longhand as well. Just hit the equals and 61056, which is 51, which is what we got for column D here, and I'm going to multiply it by 1 plus the R, which is 10%. So the 1 gives me back my 610, and the 10% gives me an additional 10%. Hit enter, and I get the exact same problem, because an annuity due basically is nothing more than a normal annuity with 1 extra period of compounding. Let's do payment. And if you take a look at the payment, I do have 1 negative and 1 positive. Has to be, or you won't get the right answer. So let's go ahead and go to payment, PMT. And I could be asking a question. Let's see. I'm going to make 30 payments, and my bankers promised me 10%. And I started with $10,000, but I need $200,000 to retire on. So if I make a series of 155.06 payments over the next 30 years, that $10,000 will grow to this $200,000. Doesn't seem like a lot, does it? Time value of money can really build up that amount quite quickly for you. So I tell people when we talk about retirement and planning and estate planning. One interesting thing with payment, and I'm going to click right here. One interesting thing with payment is if we're doing, let's say, for instance, let's just go ahead and do this problem, and I'll explain what this means first. Let's say that I bought a car or a piece of equipment, anything for $10,000. I'm going to make 30 equal payments at 5%. So I'm going to pay this thing down to 0, kind of like you buy a house or a car, not your credit card. So I'm going to just go to payment really quick. Finance and payment. And pull this over here. So at 5%, if I make 30 equal payments with something that costs, that's worth $10,000, like a piece of equipment, I have to make a series of 30 $650.51 payment. Now the cool thing about when you pay it down to 0, whether it's a house or car, and I just for the fun of it, really quick, let's go ahead and do and probably won't have one of these on the exam, but if you want to know this, how to do this for a house, this is how I do house as well. If you want your house payment, I go to rate. Now the cool thing about rate here, and I haven't talked about this yet, but 5.25%. You see it converted to rate. But see, with a house, the cool thing about a house is the interest is compounded monthly, so I'm going to divide it by 12, and I'm going to make 12 times 30 payments, 30 years, 12 payments a year, or 360 payments. And let's say I bought a house for $100,000, and I leave it as positive just because it's an asset that I own. You can see here's the payment. Okay, that would be your monthly payment. Now the cool thing about these two, since the future value is 0, the amount of principal and interest going to each payment is different. So the two Excel formulas are PPMT, which means I can find, and I'm only going to do one of them, just the principal. PPMT, there's the interest. I'm going to do click. So if I do the same thing a moment ago on, let's say, this problem here, let's say I have a rate of 5%, and I want to know the 10th, there it is, 10th payment of 30 payments. It tells me right here on the 10th payment, hit OK. Oh, well, I got it up here, it's okay. It tells me on the 10th payment of 30 payments, that amount of money goes to principal, and if I would subtract this from this, that goes to interest. And you're going to see the interest will decline as the more payments you make, whereas the principal will actually go up. It's quite interesting if you want to use for the principal and interest on a payment. Let's go to rate here. Sorry about that here, but let's go to rate. Let me go ahead, and that would be the interest rate, and it's under R. Here it is. So here's a good question for you. If college costs, I don't know, let's say 25 years ago, college used to be $700 a semester, and currently it's $4,000 a semester. and I'm going to leave payment blank. I'm going to hit OK. You can see, and it's going to round up. So let me come over here and whoops, round down a little bit. You can see that, and this is a true, by the way, UK U of L was about $700 a semester 25 years ago, and it's grown to about $4,000. Gives me a rate of increased amount of cost over about 7.22% per year. That's an average. It doesn't mean each year. One year could have been 7%, one year could have been 4%, next year is 8%. It just shows me an average increase in value of the cost of education. Let's look at this one, N per. And I'm going to go to formulas, finance. Oh, I passed it. There it is, N per. So here's a good question. At 8%, making $4,000 payments each year, and starting with $5,000 in the bank, I want to retire on $250,000. So hit OK. It's telling me it's going to take me 22 years to reach that goal. That means I put $5,000 in the bank today. I make $4,000 payments each year starting 1 year from now. All that will grow to $250,000 at 8% over 22 years. Now, this is the one we did on week 6, the net present value. And that's when our annuities were no longer annuities. The payments were actually a different amount. So it gets a little tricky here, except Excel makes light work of it. Just go to the formulas and finance and find NPV. There it is, net present value. Now the cool thing about this is I'm going to put my rate in here first, and I'm going to click here value number 1. And I'm just going to put the $100 in, and I'm going to stop for a moment, because what the calculator has just done for you is it's taken that $100 and basically used the same math we did over here and discount that $100 back over one period at 10% and says that's $90.91. Now when I populate value 2 with number 200, it's now going to discount that one back over 2 periods at 10% and add it to the $91, and now it's already added it to it. Hence the word net. It's adding each of those present values up. Click value 3. Now it's discounted that back 2 periods at 10% and added it to our $256, and now we have this. And you can just keep doing this all day long. There's many problems. It's done it again. And then let me pull down and get to the next one, value 5. Hit OK. Pull this up a little bit there. There we go. So it's telling me that you would be indifferent, kind of like this problem we did here, except the difference is the $1,000 was not equal. They were unequal. So you'd be indifferent to this amount today or those in the future. And that becomes very important when we're doing stock valuation, because in stock valuation, you may say, I'm going to get this much dividend year 1, year 2, year 3, and it grows, and then maybe year 4, with the stock value plus the dividend, you have to discount those different numbers back to find out what the value of the stock is, or the value of a company is, or again, a piece of equipment that has different cash flows in the future. It's really simple to do with Excel. Now, let me pull this down a little bit here. I'm going to pull this just for this. I want to pull these here. Well, before I get these last two, I want to mention something. If you're doing net future value, can't do it. You got to kind of do it longhand. You have to do each individual. And like, for instance, if I want to know what the future value would be of $100 1 year from now, 200, 2, 3, 4, 5, what would all those cash flows be worth in the future, not the present? You have to do each one of them individually using this math here. Or here's the trick I always use here. I'm going to populate this for instance. If you're looking for net future values of unequal cash flows, I always tell students to find this number here. And once you find that number here, just do it simply this. Go to FV. And I'm going to go ahead and put 10%. I'm going to type this one in, 10%. And I'm going to say 5 years, because I got 1, 2, 3, 4, 5 payments here. And I'm not going to put payment. I'm going to put 0. And I'm going to start with a negative 1065.26. And there's my answer. Click. You're probably asking what that's going to mean. If you were to take this number and you go out 1, 2, 3, 4 periods at 10% and put that number there, and do this one at 1, 2, 3 periods and put that new number, this one at 1, 2 periods at 10%, 1 period, and then just add 500, you'll get that number here. we don't really do these very often. There's not really a need for those, but that's, I guess, a quick way of doing it. Now, lastly, there's a section there that says other compounding periods, because so far, if you've noticed, who gets 10% each year exactly at the end of the year? Well, if the banker says I can give you 5% on your CD, what the banker is really saying is 5% is nominal or quoted or stated or APR, but I'm going to compound a little bit every day, daily. And when we do that, we have to find its effective rate. So I'm going to watch this really quick. If you got a credit card that's paying you 18, that's your cost charging, you're being charged 18.99, it's compounded daily, just go to Finance and just look for effect, A, B, C, D, E. There it is right here. Click. And you can see here's the nominal rate. And let's say 360. And 360 is usually how bankers do it. You can see there's your real rate. You're actually being charged 20%. And it's kind of cool if you look on your credit card statement. It shows you on a monthly basis by taking that number here and dividing it by 12. Enter. It actually says you're being charged that much each month. And you can do the opposite. That means if you know that your effective rate is 21%, you're being charged monthly, just go to Finance and go to Nominal. So we can kind of go backwards and forwards on these here to see what the APR would be if you have an effective rate. And there it is. So in essence, you're saying that's your effective rate and you're being charged monthly. Okay, so there's your actual nominal amount, and that's effective amount. And if you see here, I was going to do one, we've already did it here, of a house payment. And the cool thing about a house is it's one of the only things in which you pay monthly and the interest is compounded monthly. So I always say here, just take your interest rate you're being charged, your rate, divide it by 12, and take your payment and multiply it by 12. So you had 30 years of payment times 12 is 360, and you'll get that. And the cool thing is, don't forget, if you have this, you can go any one of your payments and get the interest and principal for payment. So in essence, we've done just about every problem you can do on any of these. And here's all your, I guess, financial functions. This one wasn't a function here, or this one we used the IPMT and the PPMT. And I didn't put IPMT there. I can put IPMT. These were found within those. So 1, 2, 3, 4, 5, 6, and of course your NPV right here, 7. Those 7 Excel formulas pretty much will answer every question you've got on the test. I hope this helps.